Hello everyone. So now let's do two examples of integral by substitution where we have to use the original substitution to completely transform our integral into a pure integral that depends on u only. So here we have the integral of x square root of x minus 2 dx. Here the only interesting possible substitution would be the inside of the square root. So let's try that. So let's say u is equal to x minus 2. So when you compute du with respect to x, d of x is just 1. So here if you isolate dx, you get that du is equal to dx. So we have a formula for x minus 2. This will be turned into u, and dx will be turned into du. So very clean initially. So here we have the integral of x square root of u du. But here, if you try to simplify anything, there's nothing inside the formula of dx that can be used to get rid of x. So you cannot get rid of your x here. So when you cannot get rid of your x, things are rough. So when that happens, well, sometimes it happens because you're not applying the right technique. Of course, at this point in this section, there's only one technique. Okay, so we know there's a way. Okay, so here the idea is that sometimes when you cannot get rid of what's in front of your integral or inside your integrand, you have to use the original substitution and try to find a way to isolate what's missing. And here I see it. I want to get rid of x here in my original substitution equation that links u and x together. I can isolate x and create this brand new equation for x. If I take this minus 2 on the other side, u plus 2 is equal to x. Et voila. So now we can replace that x with a formula that depends on u only. So here x now blossoms into this nice formula. So we get this brand new integral. So we get the integral of x. Now x is u plus 2. Square root of x, I'm going to use the power of square root because I know I'm going to do some integration at some point. So that's u to the 1/2 du. So now there's no longer any x's. You feel better about u. I love substitution so much. But you can't integrate still. There's a multiplication, but that's all right. If you enter that u inside your integral, you're going to get the integral of u to the power 3/2 because we have u to the power 1 times u to the power 1/2, which is u to the 3/2, plus 2 u to the power 1/2 du. Now you have a bunch of power rule to apply. So this will become u to the power 5/2 over 5/2. So you just go 3/2 plus 1 plus 2 u to the power 1/2 plus 1, which is 3/2 over 3/2 plus c. And then the last step is to replace u by its original formula with respect to x, which is x minus 2. Here I'm going to clean those fractions by flipping them. So when you divide fraction, you can just flip them. So over 5 over 2, so that's the same thing as 2 over 5 u, which is x minus 2 to the power 5/2 plus 2. So if I flip my fraction, so no plus 2. So if I flip my fraction, I multiply by 2 over 3, so we get plus 4 over 3 u, which is x minus 2 to the power 3/2 plus c. All right, so that's the example where sometimes you need to use the original equation, the original u substitution, and try to find what's left in your integral to get rid of using that equation. So it's a very, very important thing to remember is that the original u substitution equation can be used sometime, okay, to do that. All right, for that example, that's it. All right, let's do another example similar to this one. So we have to integrate x5 times the cubic root of x cubed plus 1. So here we go again. So let's use the inside of the cubic root for u. So u is equal to x cubed plus 1. So then when you compute du over dx, you get 3x squared. If you isolate dx, you get du over 3x squared is equal to dx. So we have a formula for u. It's x cubed plus 1. We have a formula for dx. So here we go. So we have the integral of x5 cubic root cubic root of u. And the cubic root of u, I'll just write it right away as u to the power 1/3, and then dx is just going to turn into du over 3x squared. So we simplify this expression, but we see that we don't get perfect cancellation. So when you cancel x squared and you simplify it with x5, you're left with x cubed. So here, the new power is x3, so we get this integral of x cubed u to the power 1/3 du over 3. And the problem is this x cubed here, it's in the way. And even after simplification with the 3x squared, we're not getting rid of all our x's. But what a coincidence here, we have an x cubed inside the original u substitution formula. So we can use it and create this new equation for x cubed. So if you isolate x cubed, you'll get u minus 1 is equal to x cubed. So now we have a formula for x cubed. It's u minus 1. Let's put the over 3 up front. So that's 1/3. Now x cubed is u minus 1 times u to the power 1/3 du. Et voila, a pure integral that depends on u only. Let's introduce the u to the power 1/3 inside. So you have 1/3 times the integral of u to the power 4 over 3. So here I'm just multiplying my powers. 1 plus 1/3 is 4/3 minus u to the power 1/3. I'm not integrating here. I'm just distributing the u to the power 1/3. And now I have my pure integral with respect to u. So I get 1 over 3. Now I just raise my power. So you get u to the power 7 over 3 over 7 over 3. Minus, so big bracket here. So let's make sure you multiplying properly. So u to the power 4 over 3, using my power rule, over 4 over 3, plus c. Now if you simplify a bit, so divided by 7 over 3, that's 3 over 7. Same thing for 4 over 3, it becomes 3 over 4. If you multiply 1/3, I'll let you verify this as an exercise. And if you turn u into its original formula with respect to x, you get x cubed plus 1 to the power 7 over 3, all that over 7, minus x cubed plus 1 to the power 4 over 3 over 4 plus c. So I'll let you figure out the algebra in between, but the point of this exercise is to realize, so for the last two examples, so when you choose something for u, you compute something for dx, you simplify. If you have some terms left with respect to x, you need to think about your original equation that links u and whatever formula with respect to x that you've chosen. And you have to look at this equation and if you can use it to isolate whatever's left into your integrand. And as you can see in the last two examples, I was able to do this, use the original u substitution equation to rewrite my integral with respect to u only. All right, so for integral by substitution, the first technique, the most important technique, of course I'm going to say that for every single technique. That's it. That's all. Okay. We're going to look at the next technique of integration, which is integration by parts, in the next section. All right. Anyways, that's it. That's all. Bye-bye. Love you guys.